Hi there, welcome to O'Reilly Maths. In this video we're going to be looking at prime factors. Now prime factors comes under the number strand of mathematics, and we're going to be looking at the concept behind prime factors. So the first thing I'd like you to do is pause this video and try and tick the correct answer for this question. What are the prime factors of 8? Okay, well, prime factors of 8 would be the factors, which is the numbers that multiply to give 8, which are also prime. So the first thing you have to ask yourself is, does 8 times 1 give you 8? Yes, it does. Is 8 prime? No. Is 1 prime? No. So these are factors of 8, but they are not prime factors. So it's not that box. Let's ask ourselves this question here. Is 2 multiplied by 4 give us 8? Yes, it does. Is 2 prime? Yes. Is 4 prime? No. So these are not the prime factors of 8. Even though 2 is prime, both of them, or all of them, must be prime. Let's have a look at the next one. 8 multiplied by 1 multiplied by 1. Yes, that gives us 8. However, 8 and 1 are not prime. 2 multiplied by 2, well, that's 4, and 4 multiplied by 2 is 8. So this does give us 8. Is 2 a prime number? Yes, it is. So 2 multiplied by 2 multiplied by 2 are prime factors of 8. And finally, 2 multiplied by 1 multiplied by 4 gives us 8. However, 1 and 4 are not prime. So the answer we were looking for was 2 by 2 by 2. Now that's all well and good, but what if you weren't given multiple choice? What if they just asked you the question, what are the prime factors of 8, and you didn't have all these choices? How would you work it out? Well, the way we do it is we use what's called a prime factor tree. So we write the number 8 at the top, and we split the number 8 into any two factors that multiply to give 8. Okay, it does not matter which numbers you pick, except for the fact that you cannot pick 8 and 1. You cannot pick the number itself and the number 1. And I'll explain later why that is. So any other two numbers. So let's go with 2 and 4. Now we know that 2 multiplied by 4 is 8. Okay, so we've split 8 into two factors. Now you ask yourself, which of these factors, if any, are prime? Well, the number 2 is prime. So I'm going to highlight the number 2. The number 4 is not prime, so I'm going to split the number 4 into two more factors. Let's go, remember we can't put down 4 times 1, so let's go with 2 times 2, because 2 times 2 is 4. And then we ask ourselves, is 2 prime? Yes. Is 2 prime? Yes. Well, then we're finished all the branches. So all the branches have a highlighted number at the end of them, which means that these numbers that are highlighted are the numbers we multiply to give 8. They are the prime factors because they're prime numbers and they multiply to give 8. So we can write the answer then, 8 is equal to 2 times 2 times 2. And another way to write that in shorthand would be 2 to the power of 3. Which means 2 multiplied by itself 3 times. 1, 2, 3. But either of these answers would be okay. Okay, so I'd like you to pause the video and see if you can work out what the prime factors for 36 are using the prime factor tree method that I've just shown you. Okay, so let's have a go with the number 36. Okay, now you may use different numbers to begin with than I do, but you should end up with the same answer. So I'm going to do this twice using two different numbers, and you can see if you have used the same numbers as me. So the first thing I'm going to do is I'm just going to say 36 is 4 times 9. So I'm good at my 9 times tables. I love them. So 4 times 9. Well, 4 is not prime, so I'm going to split 4 into 2 times 2. and 2 are prime. So I'm going to highlight them, and that's the end of those branches. Now I'm going to go back to the 9. I'm going to split the 9 into two numbers that multiply to give 9. Well, 9 is equal to 3 times 3. And remember, 3 and 3 are prime numbers, because the only factors for 3 are 3 times 1. So there we have all the branches finished, and we've got 4 numbers highlighted. So 36 is equal to 2 times 2 times 3 times 3. Now you can write these numbers in any order because of the commutative property, which you can learn about in a previous video. And you can write this answer a little bit shorter and neater. 2 by 2 is just 2 squared, or 2 by itself 2 times. Multiplied by 3 by 3 is just 3 squared, or 3 multiplied by itself 2 times. But either of those answers will be okay. Now I'm just going to show you how you will get the same answer if you use any other two numbers. Now obviously remember I said you cannot use 36 and 1, because then you would just be back to where you started with 36 here, and you'd have to just split 36 again. So don't use the number itself and 1 when doing prime factor trees. So this time I'm going to pick 18 times 2. Now 2 is a prime number, so I'm going to highlight that, and that's the end of that branch. However, 18 needs to be split again. I'm going to split 18 into 6 times 3. And this time I've got 3 is prime. 6 is not prime, so I'm going to split 6 again into 3 times 2. And 3 is prime and 2 is prime. So there I have the 4 numbers again, 3, 2, 3, and 2. It's the same numbers as over here. So I can write it out. It's equal to 3 times 2 times 3 times 2. Again, the order doesn't matter. It's the same answer as over here, and if you want, you can write it like this again, but there's no need unless you're specifically asked to do that. Okay, now I'd just like you to focus on the wording of this question. It's the same idea, however the wording is slightly different. It says express 45 as a product. Product just means multiplication of its prime factors. So you must write the number 45 as a product of its prime factors. So that is just basically doing what we just did in the previous questions. But I want you to get used to the language that can be used to ask this same question. Let's have a go with 45. Okay, we're going to split 45 into 9 times 5, or the first two numbers that come to my head. Are either of these numbers prime? Well, yeah, 5 is prime, because you can only get 5 by multiplying 5 times 1. 9 we're going to have to split again. 9 isn't prime. Split that into 3 times 3. 3 is prime, 3 is prime, and there we're done. 45, I'm going to write it now as a product, meaning using multiply signs. 3 times 3 times 5. If I wanted to shorten that, I could say 3 squared times 5. And that would be okay as well. Either of those two answers are correct. Could we have done this a different way? I think we could. Let's have a go. 45, let's split it into 15 times 3. You may not have thought of those factors. 3 is prime, so we're finished there. And 15 is 5 times 3. If 5 is prime, 3 is prime. And once again, we have the same numbers again, slightly different order. So 45 is equal to 5 times 3 times 3. That's it, written as a product of its prime factors. Okay, so the last one I'd like you to look at is this one here. It says write the number 60 in the form, this just means in the shape, 2 to the power of a multiplied by 3 to the power of b multiplied by 5 to the power of c, where a, b and c are elements of the set n. Now the set n is the set of natural numbers. These are just your counting numbers, 1, 2, 3, 4, 5, and so on to infinity. So A, B, and C are going to be counting numbers. These A's, B's, and C's are going to be counting numbers. So they want you to write the number 60 in this form. Now what you should notice is that 2, 3, and 5 are prime numbers. So really all they're asking you to do here again is to write 60 as a product of its prime factors, or to find the prime factors of 60. So let's begin. I'm just going to go first of all with 30 times 2. They're the first two numbers that came to my head. 2 is prime, so I'm finished with that branch. Going to go back to the 30 and split that into 15 times 2. Again, 2 is prime, so that branch is finished. 15, going to split that into 5 times 3. And 5 and 3 are both prime, so there you have it. 60 is equal to 5 times 3 times 2 times 2. Now, they are the prime factors of 60, but they want us to write it in this form here, or this shape here. So that would be equal to 2 to the power of 2, because there's 2 by 2, there's 2 of them. So that's what this little 2 represents. Multiplied by 3, multiplied by 5. Now, you might say, well, there's no number here beside the 3. Well, 3 to the power of 1, in other words, 3 by itself, once, is 3. So 3 to the power of 1 is the same as 3, and 5 to the power of 1 is the same as 5. So there we've expressed the number 60 in the form that we were asked to express it in. A, B, and C have to be counting numbers, natural numbers. So A is 2, B is 1, and C is 1. And there we have it. Let's just do this one more time using slightly different factors to begin with. I'm going to go with 6 times 10. Okay, this time neither of these numbers is prime, so I'm going to have to split both of them. 6 is split into 3 times 2. They're both prime, so that's finished. And then I go over to my 10 and I split that into 5 times 2, which again are both prime. And there you have the same four numbers again, 3, 2, 5, and 2, 3, 2, 5, and 2. Okay, so you would rewrite the answer in this form here. And that is the concept behind prime factors. They are the factors for a number. That means the numbers that multiply to give you the number that are also prime.